All right, example number 3. Another triangle. I just want to solve the triangle, meaning find all missing sides and angles. This triangle named DEF jumps out as something that you can use law of sines for. The reason being is that you have angle E and side E, which is the side opposite it. You're given both measures. Therefore, you can set up a ratio with those. Like we talked about before, here's my formulas. You can set it up either with the side on top and sine of the angle on bottom, or the reverse. Really doesn't matter. So in this case, I'm going to set up, I know I have to use E, so I'm going to set up sine of 115, which is angle E, over side E, which is 20. So I set up that ratio. Now I want to set up another ratio using another side and angle. In this case, I know nothing about angle D or side D. Remember, side D is opposite of angle D. So I can't use that because that's two unknowns, an unknown angle and side. But I know side F, so I want to set up the ratio with F. So I'm going to say sine of angle F over the side opposite it, which is 11. So this is fine. I still have one unknown. That's okay. I'm going to, again, multiply both sides by 11 because I see that would cancel out. And I've got sine of F by itself. So I went ahead and typed that in my calculator. And I got that. That's a decimal that looks like it wouldn't really make sense as an angle measure, right? Well, that's because it's not. I'm going to write that down. Sine of F is equal to 0.498, ugly decimal, right? That's sine of F. That's sine ratio of angle F. So to figure out what angle F actually is, I need to go in there and take the inverse sine. When I take the inverse sine of both sides of this equation, I then cancel that out over here, and I'd be left with the measure of angle F being equal to, and in my calculator, because that's an ugly decimal, I'm going to use that. Okay, I'm just going to hit second sine, so that's sine inverse of the previous answer. So I'll hit the previous answer. And that gets me that value of 29.899. That's the measure of angle F. Great. That's the one difference here is you have to do sine inverse when you're solving for an angle. Let's keep moving. I found my angle here. Good. I can find my third angle by subtracting from 180. 180 minus 115 minus that 29.899 degrees gets me angle D, which is 35.101. Great. Now I've got two angles and I know two of the sides already, so I can find the third side. Side D. Now, here's again the nice thing with law of sines. Oftentimes, if you have a pair, you're going to use it more than once sometimes. So I'm going to use that exact same ratio. In this case, sine of 115 over 20 is the ratio of angle and side D. Sorry, E. I want to find side D, so I need to use the ratio of angle D and side D. Because I found this angle up here was 35.101, I'll sneak it in there, I can use that angle. Over side D. Okay. This is another situation where my unknown's on the bottom, so I would cross multiply and then divide by sine of 15. You would get your final answer to be 12.689. Notice you have to use a rounded value for this angle. Sometimes you just have to, but that's why we go 3 decimal places so you can get an accurate final answer, or at least as accurate as we can be. And you've solved for the triangle.